Hello everyone, welcome to OneClass. My name is Shanjida, and today I'll be going over some commonly asked math questions both at the high school slash university levels. And I am currently a second year human biology student. And also, if anyone needs an additional schoolwork help or needs any tutoring, you guys could check out the description box below. And other than that, we'll get started right now. So the first question for today says list the first 10 multiples of 6 and then the first 10 multiples of 8. What are the common multiples of 6 and 8 in the lists? What is the least common multiple of 6 and 8? Okay, so number 1, we have to let's first find out the first 10 multiples of 6. So, which is 6 times 1, this basic timetable. 6 times 3, 6 times 4, 6 times 5, 6 times 6, 6 times 7, 6 times 8, 6 times 9, and 6 times 8. So this is 1, 12, 18, 24, 30, 36, 42, 48, 54, and 6, right? So these are your first 10 multiples of 6. Now, the next question says the next step is to find the first 10 multiples of 8. Is 8 times 1 times 2, 3, 8 times 4, 8 times 5, 6, 8 times 7 times 8 times 8 times 8. This is 8, 24, 32, 40, 48, 56, 64, 72, and then you have 88. So from all the common multiples given, um, so the common multiples of 6 and 8, you can see here, right? If you see what's common, it's 24 and 48. Okay, so these are the two common multiples of 6 and 8. So the least among these two would be 24, right? So the least one here is 24, as you can see, because it's the least, it's the smallest number here. So basically this is your least common factor. And yeah, so this is the solution. Correct. So the second question says list the first 5 multiples of 4 and the first multiples of 5. Which of these are the common to both lists? So this time we are trying to find the first 5 instead of the first 10. And so let's do 4 first. So 4, 4 times 1, 4 times 2, 4 times 3, 4 times 4, and 4 times 5. So this is going to be 4, 8, 12, 20. Oops, this is 16. 16 and 20. So, and over here, if we do 5, 5 times 1, 5 times 2, 5 times 3, 5 times 4, and 5 times 5, we have 5, 10, 15, 20, and 25. So from these two lists, you guys could probably say that the first, so the common multiple between the two lists is 20, right? And so this is your common multiple between 5 and 4. And so the solution is so our next question here says, establish an identity. So secant theta plus tan theta over tan theta. So we basically have to say that what it's equal to, so the end result. And so the way we're going to do this is, I'll just write this third question. So we basically have to prove that the left side equals the right side. And the way we would do this is by recalling our basic trigonometric rules. And so I'll just write the question down here. Sec theta plus tan theta over tan theta. Tan theta minus secant theta plus tan theta over secant theta, and this is equal to cos theta times cotangent theta, right? And so we basically have to prove that the left hand equals the right hand, and the left side, right side, right? So first we would say that, so the first way to approach this is we will approach this question by proving that the left side is equal to the right side. So we're going to basically deal with the left side here. So we can say left and the left hand side is equal to secant, right? So what I'm going to do here is basically factor out a secant from the first fraction here, and what we're going to have left is secant. I'm going to, so let me first write secant theta plus tan theta. Right, what we're going to do here is basically factor. We're going to find a common factor between the two fractions, which you can say that it's secant theta and tan theta. And so we're going to have our common denominator as secant theta, tan theta. And in this case, we would have to multiply the numerator with secant theta for the first fraction here, And so the next one we would multiply with tan. So we would have tan theta is times secant theta plus tan theta all over secant theta tan theta. Okay. And so since we have found our common denominator here, we can write this as one whole fraction, right? So what we're gonna do is combine this whole fraction into one. So we have secant theta and theta, and we have, so what we're gonna have here, which is, I'm just gonna multiply these out. So we have secant squared theta plus secant theta tan theta minus, we have minus, so I'm gonna multiply this out also, and we're gonna have tan squared theta, we're gonna have tan squared theta plus tan theta secant theta. Okay. And now the next step would be to basically cancel out whatever whatever cancels out. So in this case, the only thing that's going to cancel out here would be the secant theta, tan theta, and tan theta secant theta, right? Because if you multiply out the negative here, they would both cancel out. So this is 0, basically. It's gone. And so what we're left with here is we have, what we're left with is, if we distribute the negative multiplied out, we have secant squared theta minus tan squared theta. And this is all over secant theta tan theta. Okay. So if you guys recall, so since we factored it, simplified it, we can further simplify if from the identity, so from the identity, you guys recall, that you can basically say that secant squared theta minus tan squared theta is equal to 1. And so we can basically say this is equal to 1, if you rearrange it, 1 over secant. So if you take the reciprocal, we can say secant theta times tan theta. And from using that identity, we can say, so from this, we can say that, so by the identity, we can say that basically we can say 1 over secant theta is equal to cos theta, and 1 over tan theta is equal to cotangent theta, right? And so basically we say this is equal, so this is basically equal to cos theta, cotangent theta, and it's equal to your right side. So this is how you get the answer, and we just proved the identity. Solution. So our next question here says, so use a special right triangle to write sine 45 degrees as a fraction. Okay, so we call that using a right, so let me draw out a right angle triangle. Okay, where drive this. Okay, so this is your right angle triangle, and in this case we're using 45 degrees, so it's an ice, so it's going to be, this is going to be 45, this is going to be 45, because since this is 90, okay, so this is going to be 45, and this is also going to be 45, right? And so this is our triangle, and if you guys recall that sine theta, any degree basically, theta represents any degree in a triangle, and this is equal to your opposite over your hypotenuse. Okay, and since we're dealing with 45 degrees, in case of the special angle triangles, you guys know that this is equal to 1, this is equal to 1, right? And this is your hypotenuse. And so when we're computing for the hypotenuse, since we are trying to find the hypotenuse, we don't know it, the way to do that is to use a Pythagorean theorem where your c squared is equal to your hypotenuse. C squared is equal to a squared plus b squared, whereas c is equal to the square root of a squared plus b squared, right? So this could be your a and this could be your b. And to compute this, we just plug in the value. You basically get 1 plus 1, you get square root of 2, right? So c is equal to square root of 2. And so by getting our hypotenuse, you can basically substitute this into this equation to find sine theta, or in this case, sine 45. So let's just add sine 45 is equal to your opposite. So in this case, we can take either side as either side of your triangle as the opposite. In this case, if we're looking at the bottom 45, the opposite would be this side, right? And if you're looking at this one, it would be this. So either way, it's still 1. And then we would just put 1 as our opposite and our hypotenuse square root of 2. And this could also be written as square root 2 over 2. It's basically the same thing. Okay, so sine 45 is equal to 1 over square root of 2, or square root 2 over 2. And this is how you write it as a fraction. All right. Okay, so our next question says, what is secant and tangent of a circle? Okay, so when we're talking about a circle, not like perfect. Okay, this is not supposed to be a dotted line, but Okay, so we have, so when we're talking about secant, so a secant line, got this. So a secant line would be something like this, okay, where it intersects 2 points of a given graph or a circle. And so this is your secant, whereas your tangent or tangent line would be where it intersects only one point, like exactly one point, and this is called the point of tangency. So this is tangent, or like the slope of one point, right? So this is basically secant intersect 2 points, intersect 1 point specifically. Okay, and so this is what a secant and a tangent line like. Okay, so our next question says complete the identity of this trigonometric function, equation, expression, and so this one says to basically see what this is equal to, and let me write this as sine x over cos of x plus cos x over sine x. This is equal to what, right? So in this case, we have, you guys can see we have two fractions here, and so the first step would be to combine it into one whole fraction. And to do that, we have to first find the basically common denominator. And in this case, you can see there's nothing in common, so we're gonna have both of the denominators as the common denominator. And in this case, it would be cos x sine x. And you can imagine that we're going to basically crisscross and you multiply. So multiply sine x times sine x, and sine x plus cos x times cos x. Okay, and if we combine this, we have sine squared x plus cos squared x all over cos x sine x. Okay, I just distributed this, and now, so if you guys recall that um, from the Pythagorean identity, so from Pythagorean theorem, we have sine squared x plus cos squared x is equal to 1, right? So we can apply this to our fraction here, and we basically have, one, right? I just said sine square x plus cos square x is equal to 1 over cos x sine x. And we can basically further simplify this, break this down, but with having two individual fractions. And to do that, we can have this could equal to 1 over cos x, right? And times 1 over sine x. And you can probably guys could recall that 1 over cos x is equal to secant, and sine 1 over sine is equal to cosecant x, right? And so basically what this equals to, what our equation, our expression equals to. So we write this sine x over cos x plus cos x over sine x is equal to secant x times cosec. Okay, so this is what it equals to. And so this is correct. Yeah, next question says find the exact value of the expression tan pi over 6 minus cos pi over 6. Okay, so just writing this tan pi over 6 minus cos pi over 6. Okay. So they're telling us to basically find the exact value, means we have to find it in a fraction. And so to do this, if you guys recall, so let's first break this and say that first let's deal with tan pi over 6. So tan pi over 6. So when we're dealing with pi over 6 radians, we want to convert it into degrees. We can first convert this to degrees. You guys recall that pi is equal to 180, okay, and where 2 pi is equal to 360 degrees. And so we can basically evaluate this by saying tan 180 over 6. Oops, 180 over 6. This is equal to tan of 30. And so if you guys recall that tan of 30 is equal to 1 over square root of 3, right? From our triangle, special case triangles. And so the next step would be, now let's find what cos pi over 6 is equal to. So we can basically say that this is the same thing as cos 30. And cos 30 is basically root 3 over 2 from our special triangles. And so now since we found our fractions, we can use this to evaluate them by substituting into the equation basically. So we have tan pi over 6 minus cos pi over 6, and this is equal to So for tan, we had 1 over root 3, and for cos, we had root 3 over 2. Okay? And so we have to make a common denominator. And to do that, our common denominator in this case would be root 3, 2 root 3. So we can basically say that our common denominator would be 2 root 3, and we have 1 minus, well, we have let me write this. So we have 2 times 1 minus root 3 times root 3. And you can further simplify this by saying 2 minus 3, right? So root 3 times root 3, the roots get canceled out basically, and you have, it's going to be 3, and you have 2 root 3. Further simplify this, you have minus 1 over 2 root. And so basically, tan pi over 6 minus cos pi over 6 is equal to negative 1 over 2 root 3. We have, what is 3 pi radians in degrees? Okay, so now we have to basically convert the given radian into degrees. So they're asking us, what is 3 pi over 2 radians or rad? Okay. So in order to do this, there's a conversion factor basically. So we can say, if you guys recall that if you guys recall that a pi is equal to 180 degrees, whereas 2 pi is equal to 360 degrees. And so the conversion unit would be, so if you're going from 3 pi over 2 radians, this is going to be equal to basically your radians times the given degree you want to get, so 360 over 2 pi, right? And so in this case, we would have 3 pi over 2 radians, right? This is a radians times 360 over 2 pi. And so this gets canceled, and we have 180. And so you have 180 times 3, and divided by 2, you get 270 degrees. So you have 3 pi over 2 radians is equal to 270 degrees. You could also done it another way, where your 3 times 180 over 2, this is basically the same thing we just got here, and this is also equal to 270 degrees. So, right. Okay, so our next question, right? If so write log 50 in terms of a, and okay, so we're given that so given, okay, log 2 is equal to a, so we have log base log base 10, since it's nothing's given on the base, so we assume it's 10, is equal to a. And so they're telling us to write log 50 in terms of a. So if you guys recall the following properties of the logarithmic expressions, so the basic formulas, we have so log logarithmic expression. So we have, so first off, we have log base n of a is equal to x, which you can convert this into exponential equation. So we have n to the power of x is equal to a. Then the next one, we have log base n, we have a times b is equal to log base n of a plus log base n of a. And so the next one, we have the third one, we have log base n a over a divided by b, and this is gonna be log base n of a. So in this case, your base has to be the same in order to be able to do this. The log base n of b. And lastly, we have log base n a to the power of b, and this is b log base n of a. Okay. So these are our 4 logarithmic expressions, and so with these properties in mind, we can try to think of an expression that will give 50 as the answer. So we can basically say that we can basically come up with a multiplications or common multiples of 50, whatever equals to 50, right? We can say that 50 times 1 is equal to 50. 25 times 2 is equal to 50. And we could also say that 100 divided by 2 is 50, right? So since the base of a logarithmic function is 10, right? Since it's not really said, so we assume it's 10. So it would be easier to deal with the 100 over 2 pair of numbers, right? Since it will be easier to deal with 100 when you have a base of 10. And so we can say that we can basically write a new expression by saying that log base 10 of 50 is equal to log is equal to log of 100 over 2. Okay, and so this would yield So you can rewrite this by using that property of log a over log base n a over 2, a over b, and we have log 100 minus log 2. Okay, so we have this, right? So what I mean, we basically just used the third, we basically used this equation right here. And so now we can basically say what we can write this in the terms of a by simply using another step by saying log base 10 of 100 is equal to x. Whereas if you want to convert this into an exponential function equation, we have 10 to the power of x is equal to 100, right? And so in this case, x is equal to 2, right? So since 10 to the power of 2 is 100, so x is equal to 2. And then substituting this, we have, so substituting that, we have, we can basically say log base 10 of 50 is equal to 2 minus a as our equation, since we just so we just put this, we just rewrote this as 2 minus a, since we're given that log, log base 10 of 2 is equal to a, and we just said that log of 100 is equal to 2, so we just said that log of 50 is equal to 2 minus 8. Right? Since we just proved that log of 100 is equal to 2, and log base 2 is equal to a, which is already given. This is your answer. This is your answer. So the next one says 7 is 3.5 times as large as the same number. What is the number? So when we're dealing with this type of questions, we just assume, so we would basically set a variable to the number we're trying to figure out. So let's say that let's just say let n let n let n be the number, right? The number we're trying to figure out. So according to the question, we have here which says 3.5 times the number we're trying to find is equal to 7. So we say 3.5 times the number, right, which is n, is equal to 7. So to figure out n, right, this is basically a simple isolating question where you have to isolate n and find the number. So in this case, what we're going to do is move everything that's with n to the other side. In this case, n be isolated, and we have n. We move this over here, right? Since it's multiplying, the opposite sign would be applied, and you have division. So you have 7 over 3.5. And so your n is equal to 7 over 2.5 is equal to 2. So hence your number is equal to says how do you solve for x? So this is supposed to be 12 minus is equal to minus 4 minus 6x minus 3. Okay, so I'll just write out the question here. So we're solving for x where we have oops, solve for x. Solve for x and you have 12 is equal to minus 4. So solution minus 6x minus 3. So we're basically trying to solve for x in this case. And so the first step to do this would be to move everything that's attached to x to the other side. And to do this, let's first move the 4 to the other side since it would be easier. So we have 12. If you want to move 12, it's going to come to this side and it'll be divided by 12. And so you have 12 over divided by negative 4, and you're left with negative 6x minus 3. And so you have once you do the math here, you have negative 3 is equal to negative 6x minus 3. And what we're going to do is the next step will be to move the 3, negative 3 to the other side. And we have negative 3 plus 3, since it's going to change its sign when it goes to the other side. And you have minus 6x. So minus 3 plus 3 would be 0, is equal to negative 6x. So what we have here, so to get x by itself, you would have to remove the negative 6. And the way you would do that is divide the side, to bring it to the other side would be, you would divide it by 0. It would be 0 divided by negative 6. So you have 0 over negative 6 is equal to x. So 0 divided by anything basically would be 0. So basically x is equal to 0. Okay, so our next question says, which expression is equivalent to the expression below? Okay, so what we're trying to do here is basically simplify the expression, the given expression, to see what it equals to. And so I'll just write this out. We have here x over x plus 4 all over 4. Oops, all over x. Okay, so we basically have to simplify this question and to see basically which of the choices given is equal to that. So to simplify this expression, we have to get the reciprocal of the divisor, so the denominator, and multiply it to the numerator, or the dividend. And to do that, we know that reciprocal of x is 1 over x, right? So we multiply that with the top, with the numerator. So we can say that x over x plus 4 x. So you basically have, so you just multiply the numerator with the reciprocal times 1 over x. Okay? And so basically, so this is how you simplify it, and this is basically, so therefore the expression would be equivalent. So this is equal to your is equal to the numerator times the reciprocal of the divisor, and so you can basically match up which of them it corresponds to, and so in this case it would be B. So the answer is, so basically what we've done here, we've just took the reciprocal of the divisor and multiplied it with the numerator, or the dividend. Okay. And yeah, so the solution. Oh, next question is, we have our next question, and it says how to evaluate okay. Next question says to how to evaluate cos of 30. Okay. In this case, we would first draw out a triangle. In this case, it would be a right angle triangle. And so I'll just write this. If you guys remember your special triangles, right, I'll just draw one. Okay. So this would be a right angle triangle. And you can basically say this is 60. And so this is, okay. And we're trying to find our cos of 30. And if you guys recall the sides, this would be root 3. This would be 2. This would be 1, right? From our special triangles. And so to find cos of 30, cos 30, right? We're looking at this angle right here. And if you remember the ratio, it would be adjacent over hypotenuse, right? And so in this case, when we're looking down at this angle right here, cos of 30, we're looking at the adjacent side. So the adjacent side would be this, and it would be this, and your hypotenuse is this. So basically cos 30 is adjacent, so root 3 over 2. And so this is your answer. And so that was the end of our session. If you guys like this Q&A, subscribe to this channel, comment and share this video. And other than that, I'm Shanjida, and I'll hope to see you guys soon. Bye bye.